Hi everybody, we're going to solve the inequality of an absolute value, 7 problems in fact. Hopefully you have watched the videos on solving equations of absolute value functions first, because I'm going to kind of go fast over my setup. I'm going to make tables and I'm going to also graph these. So hopefully you watched the video prior to this one that's going to help you graph these. So the first one we're going to do is very easy, basic one. I'm going to make a little table here, a little longer. And all I'm going to do on this left-hand side is just copy down the equation. And if you recall, on my previous video, I said now you're going to write it again, but you're going to write negative. And also when we write negative, we're going to flip this sign. So since it's less than or equal to, we're going to put greater than or equal to. So what this is saying is that x is less than or equal to 5 and x is greater than or equal to 5. I'm going to graph this and show you what this looks like. Put my 0 here, negative 5 here, and 5 here. So it says x is less than or equal to 5, so it can equal 5, and greater than equal to 5. I'm going to shade this in, and it's an and statement. So since it's like this, I'm going to write this as x. I'm going to write this part here is less than or equal to 5. And this I'm going to write as x is, I'm writing to the left, greater than or equal to negative 5. Look at my greater sign. There it is. All right. And that's how you would write it, the inequality. I think it helps to graph these when you do these, write out the inequalities. All right, the next one is going to be, in my paper, absolute value of 2x minus 6 is greater than or equal to 5. So again, I'm going to draw my table. Hopefully you know how to solve, because I'm going to try to skip steps here, as usual. So I'm just going to copy this down on the left side. 2x minus 6 is greater than or equal to 5. And on this side, I'm going to write 2x minus 6 is, I'm going to switch the sign, less than or equal to negative 5. I did two things. I switched the sign of this, and I also flipped the inequality. Now I'm going to solve for both of these. I'm going to add 6 to both sides. And we get 2x is greater than or equal, equal to 11, and 2x is less than or equal to 1. So x is greater than or equal to 11 halves, which is 5 and a half. So it's 5 and a half, 5.5. And this is x is less than or equal to 1 half. So I'm going to draw a number line and graph this and see what this looks like. Alright, I'm going to put my 0 down here. 1 half goes here. 11 halves go here. I prefer to leave it in fraction form. They both can equal. And it says x is greater than 11 halves, so it goes this way. And it's less than, and we're really saying it's less than or equal to 1 half. So you would write this as x is less than or equal to 1 half, or x is greater than or equal to 11 halves. Okay? The next one is absolute value of 3x. 3x minus 7 absolute value of 3x minus 7 is less than or equal to 2. I'm going to draw my table and solve for x. I just copy the left side down, and the right side I flip and switch. I flip the sign and switch, make the 2 a negative 2. Now I'm going to solve for x by adding 7 to both sides on both of these. And we get 3x equals 9 here. And on this side, we get 3x equals 5. So, no, not equals. See, y'all caught me. Thank you. So this is less than or equal to 9, and this is greater than or equal to 5. So x is less than or equal to 3. I just divided both sides by 3. And x is greater than or equal to 5 over 3. Now, I'm going to graph this so I get a visual on what's going on. Here's my 0. 5/3 here, 3 here. They both can equal it. It says it's less than 3, but greater than 5/3, so it's in this area. So basically, x is in between 5/3 and 3. And you see it here. This is this portion, and this is this portion. Okay, I just rewrote this as 5/3 is less than or equal to x. I just moved my x over. Okay, the next one is 5 times absolute value of negative 3x minus 1 is less than or equal to 15. Before I do my table, I want to clean this up. I wanted to make it as simple as possible to make my table. So I'm going to divide both sides by 5 here. And I get the absolute value of negative 3x minus 1 is less than or equal to 3. Now I do my table. So do my table here. Let me just draw a line here. So we're going to get take away the absolute value, and you're going to get negative 3x minus 1 is less than or equal to 3. Just copy it down. And on this side, you flip the sign and switch the number from 3 to negative 3. You're going to solve for x by adding 1 to both sides of the inequality. So you get negative 3x is less than or equal to 4, and negative 3x is greater than or equal to negative 2. Divide both sides by negative 3. Oh, when you divide by a negative, let me show you this. You probably already know this. When you divide by a negative, you have to flip the sign. So when I divide by negative, I'm going to get x is greater than or equal to negative 4/3, and x is less than or equal to 2/3. All right. I'm going to draw my little number line. I'm going to put my 0 here, negative 4/3 here, and 2/3 here. They both can equal it. So I'm going to color in my circles here. And greater than and less than. So this is another and statement. And I just write x is in between negative 4/3 and 2/3 inclusive. It includes the 2/3 and the negative 4/3. Okay, the next one is absolute value of negative 8x plus 1 let me make my 1 like this so you can tell that's a 1. Less than or equal to negative 2. So let's see what happens with this. I'm going to draw my table. I get negative 8x plus 1 is less than or equal to negative 2. And negative 8x plus 1 is greater than or equal to positive 2. I subtract the 1 from both sides. You can do that. And when you divide both sides by negative 8, so I'll show you that. Negative 8, negative 8, negative 8, negative 8. You're going to get x, and remember to flip the sign when you're dividing or multiplying through by negative. It's greater than or equal to 3/8 because 2 negatives make a positive, and x is less than or equal to negative 1/8. All right, and so we're going to draw the number line and see what this looks like. Here's 0, 3/8, negative 1/8. It can equal it, and this is a split. You see it split? That means it's an or statement, and you just copy these down. So I'm going to start from this side though. X is less than or equal to negative 1/8, or x is greater than or equal to 3/8. Okay, we have 2 more. We have 2 times the absolute value of negative 5x minus 7, and then minus 5 is greater than or equal to negative 3. First thing I'm going to do is do PEMDAS backwards and clean this up. So I'm going to add 5 to both sides. Basically, I'm just adding 5 here. All right, and then I'm going to divide both sides by 2. And we've done enough of this if you've been watching the videos to know how to do that. All right, so I'm going to copy this side down. Negative 5x minus 7 is greater than or equal to 1. But however, on this side, I'm going to flip the sign and switch the 1 to a negative 1 because it was positive. I'm going to add 7 to both sides. Okay, and then divide both sides by negative 5. That means you have to flip the sign. I'm going to draw my number line. Negative 8/5. They're both colored in. And it's x is less than negative 8/5, but positive, it's greater than negative 6/5. So x is less than or equal to negative 8/5, or x is greater than or equal to negative 6/5. It jumps here. That's your or. Sometimes you use the unite sign. Okay, the last one we're going to do is 3. Let's see if there's any tricks to this one. You know, the last one's always the hardest, it seems like. All right, plus 2 is less than or equal to 5. I'm going to add 2 to both sides. I'm going to subtract 2, sorry. And then divide both sides by 3. So I do my little table here. Copy this down without the absolute value sign. And this side, flip the sign. And switch the numbers. It was positive, so now we're going to negative. We're going to add 6 to both sides. No, subtract. We're subtracting 6 here. So we're going to get And negative 5x is, greater than. We're dividing by a negative, so flip the sign. Dividing by negative 5 here. And so you divide here. All right, so I'm going to graph this. Let's graph it this way. Put my 0 here, my 1 here, and my 7/5 here. Color it in. The circles. It is less than 7/5, but greater than 1. So that means x is in between 1 and 7/5. And that's all.